The first part of this section is talking about the counting principle, so I'll show you the following problem. It says the sporting goods store offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. How many choices does the store offer for snowboarding equipment? So the most basic solution is to draw out a tree diagram and count the number of branches. You can buy all mountain board with soft or hybrid boots, freestyle board, soft or hybrid, carving board with soft or hybrid boots. There are 6 total choices. However, this is like way too basic when we get into when we start having a lot of options. This question's a little more advanced. It says you're framing a picture. The frames are available in 12 different styles. Each style is available in 55 colors. You also want blue matte board, which is available in 11 different shades of blue. How many different ways can you frame the picture? So you have 12 choices for the frame, 55 choices for the color of the frame, and 11 different choices for the matte board. So you do 12 times 55 times 11, and that's going to give you 7,260 options for how you want to make this frame. This next question makes it a little more difficult. It says, standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. A, how many different license plates are possible if letters and digits can be repeated? So for the first letter, there's 26 choices. For the first digit, there's 10 choices. For the second digit, there's also 10 choices because you can repeat the same number. Then there's 26, 26 times 26. So all of those together gives you 45,697,600. So 45,697,600. However, the second question is more interesting, where it says how many license plates are possible if letters and digits cannot be repeated. So that means for the first time you pick a letter, you have 26 choices. 26. First time you pick a number, you have 10 choices. Second time you pick a number, you only have 9 choices left. Second time you pick a letter, you have 25, 24, and 23. Because each time you are not allowed to use the same letter. So this is if the letters and digits cannot be repeated. So multiplying all those together, we're going to get 32,292,000. So less choices than if you can repeat the letters and digits. So that was all about the counting principle. Now we're going to talk about permutations. And permutations are ordering of objects. So let's say you want to find out how many ways you can order the letters A, B, and C. Well, you can do A, B, C. You can do A, C, B. BAC, BCA, CAB, and CBA. Those are all the ways you can order those letters. However, we don't really need to do all the work for that. When we need to find permutations, that's when we're using factorial. So there are 3 options. It's 3 times 2 times 1 equals 6, or 3 factorial, which is equal to 6. And in the calculator, you can find it by pressing 3 and hitting math, going over to probability, and choosing factorial. And then it'll say 3 factorial equals 6. So like we said, factorial is useful if we want to know, what order things come in, when order is important. So it says 10 teams are competing in the final round, the Olympic 4-person bobsledding competition. And how many different ways can the bobsledding teams finish the competition? So in how many ways can they get 1st through 10th place? So if there are 10 teams, the answer for A will be 10 factorial, which is 10 times 9 times 8 times 7 times 6. Of course, on the calculator, we just hit 10, math, probability, factorial, and we get 3628800. So 3,628,800 different ways that these teams can line up. In the second question, it says, how many different ways can 3 of the teams finish 1st, 2nd, and 3rd to win the gold, silver, and bronze medals? So what that means is we care about all the choices because all the teams have a chance. However, we only care about the first 3 places. So we only care about the 10 times the 9 times the 8, and that's going to give us 720. So we only care about 1st place, 2nd place, 3rd place. We have 10 choices for 1st place, 9 choices for 2nd, and 8 choices for 3rd place. Because after a team gets a place, they can't go on to win 2nd place and 3rd place as well. It's important to clarify this question because there's actually a formula to go with it. Now, the way I described it is the way you should probably think about it, but really what it's called is the number of permutations of 10 objects taken 3 at a time. So the way we express this in mathematics is, of 10 objects, we want the permutation of 3 of them. Of 10 objects, we want the permutation of 3 of them, which is really 10 times 9 times 8. However, the way we express it is we put 10 factorial over the number of total permutations minus the amount we want, factorial, which is 10 factorial over 7 factorial, which is once again just 10 times 9 times 8 because the rest of those numbers cancel out. The 7s cancel out, and the 6s cancel out, and the 5s cancel out. So, I mean, that equals the same thing as we got before. It's still just 720. But this is the way it's expressed. Out of 10 objects, we want to know about 3 of them. So we do 10 factorial over the remaining 7 factorial. So if you see a question like this, and it says 5p3, it says out of 5 objects, we want to know about 3 of them. So 5 minus 3. 5 factorial over 2 factorial is equal to 60. Because it says out of 5 objects, we care about 3 of them. We're going to divide by the remaining 2 that we don't care about and get 60. Or you can just read it as out of 5 objects, do 5 times 4 times 3. Do it 3 times, but don't go all the way. So you can't just press 5 factorial. You need 5 factorial over 2 factorial. So there's like a couple ways to think about this. You guys got to choose the way that makes sense to you. The last question says, find the number of distinguishable permutations of the letters in Miami and Tallahassee. So it says distinguishable. It's because you can tell them apart, because Miami has some letters that repeat. And so some of the orders of these things will actually look the same because there's 2 M's. You wouldn't know which M is which. Same with Tallahassee. So the way you solve this is, Miami has 5 letters total, divided by the things that repeat themselves. So M repeats itself twice, times I, which repeats itself twice. So you have 5 factorial divided by 2 factorial times 2 factorial, which is equal to 120 over 2 times 2, which is equal to 30. So there are 30 different ways to arrange the letters in Miami. Well, 30 unique ways. For Tallahassee, there are 11 total letters. Let's see, the A repeats itself 3 times, so we have to divide by that. This L repeats itself twice. The S repeats itself twice, and the E repeats itself twice. So 11 factorial divided by these, that's going to give us 831,600.